Hey guys, how are you all? Hope you are doing well. Welcome to my channel. So it's really amazing atmosphere over here. So today it's a great announcement for me to inform you that we are going to start our tutorials. So basically mainly on statistics required for a data scientist, and I'll also be discussing about optimization methods required for a data scientist, and what are the techniques we will learn, especially in terms of mathematics, in terms of an optimization techniques, guys. So today I'll be explaining, giving you an overall topics on what are the statistics that is required, and those concepts are going to cover in my subsequent videos. And in addition to that, I'll also be giving an overview of optimization techniques, what exactly is optimization technique, and what we are going to cover in optimization techniques as well. And parallelly, this series will be a long going sessions, guys. So it will be taking up to more than a year so from now. So I'll be uploading videos if on a daily basis, more probably. If not, might be on a two days basis. So, and once again, I really hope you guys are doing well and keeping safe, guys. So let's jump into our discussion, so that I'm going to talk about the statistics required for a data scientist and the various topics in statistics required. So the first thing is, guys, why do we need statistics, guys? So let's understand, rather than learning statistics. So why we need statistics, guys? Because of data. So is it because of data or any other part? So it's not only the data, guys. So the main reason is, from that data, if you want to make certain assumptions, so in order to identify certain trends, we need to understand minimum statistics required. So statistics can be starting with mean, guys. So mean, generally, if you want to take any of the assumption, right, if the movie is good or bad, we'll just try to take an average. So that doesn't mean internally everywhere statistics is applied, but data scientists practically will says that mean is not only the statistical term. In addition to that, we have various statistical terms called median, mode, in order to measure methods of dispersion. Dispersion is basically the spread. So in order to measure that, we'll basically be talking about standard deviation. So it's not only about square root of we'll be trying to calculate the average from the value from the mean, and trying to sum it all the squares and then taking it an average by total number of values. Not that, guys. I'll try to talk about why are we taking an average and the difference between that, and why are we squaring it up. What if I didn't square? What might be the value? So rather than squaring it up, why can't I take average or modulus of the difference between the value, actual value, from the mean? So we can take that. So I'll be talking about those techniques as well. And finally, about variance. So it's not only about square root of standard deviation, guys. It's a that, but why are we taking variance? Standard deviation is already a method of dispersion. Why do we need variance, guys? So I'll be talking about this history behind these techniques as well, guys. And that's the overall scenario, guys, assumptions that I get. And our roadmap will be as follows, guys. So, and from tomorrow, guys, from the next video, I'll be purchasing a tab, so that I'll be explaining in my tab, so that that will be visible to you guys as well. So till then, please don't mind for today alone. And from tomorrow, hope you guys will be having a clear idea on what I'm going to explain. So hopefully try to catch up from tomorrow and even from today as well. So first, basically, I'll be talking about what exactly is statistics and the various kinds of data, and what are the various kinds of data and how we can visualize the data. So that's where visualization comes into the picture. So once that is done, guys, we'll try to understand about the data and the various kinds of data that we are having in real time. And after that, we'll also be try to taking about average, guys. So average is basically mean. So from mean is already a measure of central tendency. Why do we need median, guys? So it's simple, guys. So median is all about if the total values in a given set is even, then we'll try to take between middle of average, middle two values average. If it is odd, then we'll simply take the middle one. But why are we taking it, guys? Mean is not mean. Isn't it mean sufficient enough to derive a certain statistical term or certain inferring from a given statement. I'll be talking about mean is sensitive to outliers, guys. Remember this point. So how we can overcome this using median? I'll be talking about that. So how median is not sensitive to outliers and even mode. So these are the, I'll be talking in detail about why mean is not sufficient enough and why median came. What did scientists really thought that it's really required for median, guys, and also of course for mode as well. And then in order to measure measures of dispersion, I'll be talking about the standard deviation, variance. Suppose this chance, after this, I'll also be talking about probability, guys. So probability mostly we learned in our higher school standards. So about probability, what is probability? We know in order to probability is predicting a chances where it lies in between 0 and 1, the probability of getting a chances for a success event. So it based upon the examples that we choose from a deck of cards, flipping a coin. If you want to find out how many consequent tiles, if I toss 2 coins, what might be the probability that I'll get 2 tails, 2 heads? So we have to come up with the various possibilities, and then we'll try to predict this particular probability. So hopefully I'll be talking about all these techniques. And in probability, we'll be mainly talking about various kinds of probability methods like conditional probability, which is mainly used for Bayes theorem, and mutual inclusive, mutual exclusive, sample event, sample space, random space. These are the various techniques, guys, I'll be going to cover with an advanced examples as well. And once this is done, then mainly we'll also be talking about probability distribution functions as well, guys. So we'll also be talking about that. And apart from that, I'll also be talking about the arrangements, guys. So that's where permutation and combinations comes into the picture, guys. So I'll be talking about how a given students can be arranged in a given classroom, in a seat room, how a persons can be arranged by sitting each next to one in a particular classroom. So there are various kinds of examples that I'll be going to talk about, guys. And next thing is about keeping things discrete, guys. So it means I'll be talking more on about the distributions, guys. Geometric distribution, the Gaussian distribution, binomial distribution, Gaussian distribution, normal distribution. These are the various distributions I'm going to cover, guys. So, and beyond the normal distribution, what and all are the other normal distributions that we are going to cover? That also I'll be discussing, guys. And apart from that, we'll also be discussing sampling. So sampling techniques, so which includes random sampling, stratified sampling. There are various sampling techniques, guys. So I'll be discussing about that as well. And finally, coming up with the predictions. So once you come up with the predictions, how accurate the results are. So we have to invest more time on getting the accuracy. So for that, we'll also be understanding calculation affecting metrics in statistics, which includes classification, precision, true value, and even for regression techniques, we'll also be discussing about R squared, adjusted R square, coefficient of determination, coefficient of correlation, Pearson correlation coefficient, various techniques, guys. And to improve an accuracy of a model, we have to fine tune and use hyperparameter tuning techniques, guys. So which includes ridge regression, lasso, grid search CV, randomized search CV. So I'll be also talking about all these once if I implement a project, right, guys. I'll be sharing my screen and I'll be giving a walkthrough on this entire project that I will be starting soon. So first I want to give a clear-cut idea about the statistics techniques. And apart from that, we'll also be looking up at the evidence tests, guys. So once if we are assuming an evidence is going to happen, how good is that? So is it really true, the assumption that we assume? So this we are going to discuss using hypothesis testing, guys. And finally, in the end, we'll also be discussing about regression techniques and classification techniques. So this is the kind of roadmap that I prepared myself, guys, that to discuss mainly in statistics. And now the topics which I said till now. So we'll be talking all these topics with an example, guys, so that you'll really understand about the statistics behind an algorithm. See, guys, I'm not directly jumping into any of the algorithm like linear regression, logistic regression, decision tree, random forest, randomized the search tree optimization techniques, ridge regression, lasso, and In random forest we have various boosting algorithms. So I'm not directly jumping into those algorithms, guys, because I want to take sessions especially on statistics. And the next important thing is I'll also be taking parallel optimization methods required for data science. So here I'll be taking an examples mainly on mathematics, which talks about linear programming, functions. So if we have an example, so I'll be talking about what exactly is optimization, guys. So why are we trying to optimize it? So just let me give an example, guys. So basically, in order to optimize something, we'll be dealing with functions, guys. So remember that, guys. So I'll be talking about if we have a given set of events, from that, what are the various parameters we'll be considering to optimize certain thing, guys. So optimization means not only about time. So finding the best solution, guys. Here the V3, best solution, guys. So optimization means. So I'll be talking about various techniques, guys. And if we will be calculating the best possibility method solution from all the available solutions, guys. So for that I'll be taking an example, and we'll also be talking about calculus, the mathematical terms called calculus, quadratic equations, linear algebra. So from linear algebra, why we need linear algebra, guys? So I'll be talking about with an example. And from linear algebra, calculus came. Why calculus came? So there are certain things where linear algebra is not sufficient enough to deal with a certain given equations. Either it can be quadratic polynomial equations or quadratic equations. So that's where calculus came into the picture. So I'll be talking about that with an example in which instances linear algebra is not sufficient enough so that calculus can solve pretty much easily in a straightforward time. And apart from that, I'll also be talking about linear programming, guys. Linear programming. So remember the term linear programming and non-linear programming as well with an example. And mainly I'll also be talking about game theory, guys. So game theory is basically about mainly talks about the transportation problems. So where we'll be from a given possible solutions, available path, what is the best solution which we can find out with the less time, and the solution will be optimized solution, guys. It doesn't mean we'll simply run into a problem and then we'll try to pick up the solution, guys. That doesn't mean you are approaching towards an optimized solution, guys. So we'll be talking about these various techniques that are available in game theory, linear programming and non-linear programming, guys, and various graphical intuitive ways of solving those kind of problems, the optimization problems, guys. So these are the various techniques that I decided, guys. So hopefully I'll be starting these videos soon, and from my next video I'll be having a marker and a tab, so that whatever the concept that I am talking right now, I'll be writing it in a tab so that it will be visible for you guys and you can use that as a reference. So I'll provide a recap of all these lectures that I gave in my next video. And then I'll jump into the first session of statistics, where I'll be talking mainly about what is, I'll start with, guys, what is data, why data, and then I'll talk about what exactly statistics term. And after that, I'll talk about what is information. So how, if we are trying to derive it, right? So we have to understand very basic step. And then I'll also be talking about measures of central tendency, why mean, why not mean is sufficient enough? Why did the scientist come up with a median? I'll be talking about history, guys. I don't want to directly shoot a formula and say this is the median, this is the mode. I don't want to do that. Basically, we have to understand the statistics behind it. What was the history behind it? So that if you're attending an interview, so you will be able to answer basically if you remember the history, because you need not to remember the formula, guys. Mean, median, standard deviation, you need not to, because when you're implementing in a programmatic way, it's pretty straightforward. You can use the various libraries available and you can solve it. But whoever knows the relation between each of these terms, that's where you know how much depth you had, right? So that's where basically I prefer that most of the, I mean, it doesn't mean like, guys, so in programmatic, once if you start implementing it in data science, you will, no one will ask what is the median for, in, there might be a scenario where they might ask what is the relationship between variance and standard deviation, why they might ask, and they might, we also be discussing about various kind of distributions as well. So these are the various things, guys. So my tutorials will be mainly on mathematics, guys, rather than end-to-end projects in data science. So I'll be talking about mathematics mainly for the next couple of months. Post that, I'll be starting an end-to-end machine learning projects as well, that once if I start developing it. So currently I'm concentrating especially on statistics only. So that's where a data scientist has supposed to be in the initial stages of their career. So I feel this is the right time for me, and I'll also be talking about on optimization methods in data science as well. So might be in after a couple of months, as I said, I'll be talking about end-to-end machine learning projects. So that's it, guys. So and if anyone is new to my channel, there are already videos that I uploaded: roadmap to become data engineer and roadmap to become data scientist. What skill set do we need? So I currently I'm only starting with the entire end-to-end roadmap and taking the courses, especially on teaching the classes only on data scientist, guys. So if you guys have any queries, you can just ping me in a comment section. I'll revert it back as soon as possible, guys. So you can have any comment, please feel to reach out to me. Thanks a lot for having me here. Thank you. Thank you, guys. Have a good day. Bye.